Good afternoon, everyone. And as mentioned, we are all happy that you're all here joining us today. We like to see on the chat that you are enjoying these sessions, that they're very informative, that they are helping you in your classes. So as far as for today, we're going to be reviewing for your exam one. So most of you either are about to take your exam or will take your exam, your first exam next week. So we want to take this Friday to do a little review as the most important topics. Okay. So again, there'll be a link to for attendance purposes available on the chat shortly. So once it appears, please click on it so you are able to get credit in case your math instructor is giving you credit or you need the hour for tutoring purposes for a grade. Okay, so let's go ahead and get started. So the first thing that we want to do is let's find the distance between 2 points and the midpoint between 2 points. So if they give us a point, remember this is an ordered pair. This is the X, this is the Y. Now it doesn't matter which ones you pick to be your point 1 or point 2 as long as you follow the formula. Okay, so again, we have this point 8, 4 and 8, negative 6. So to find the distance, this is the distance formula. Given 2 points, you'll get the x value of the second point minus the x value of the first point and square it, plus the y value of the second point minus the y value of the first point, and you square it, and then again, it's all, and you'll take the square root of the whole thing. Okay, so let's go ahead and start. So this point here, again, we're labeling this my point 1, this is point 2, and again, it doesn't matter which one you select to be point 1 or point 2, as long as you follow the formula. Okay, so here I have 8 minus 8 squared plus minus 6 minus 4 squared. So I simplify. 8 minus 8 will give me 0, minus 6 minus 4 will give me a negative 10. 0 squared is 0, and negative 10 squared is 100. So 0 plus 100 is the square root of 100, and the square root of 100 is 10. So again, the square root does give you a positive or negative, but there's no such thing as a negative distance, right? So we're only interested in the positive one. So on this particular one, our distance is 10. Okay, all right. So let's find the midpoint. So this is the formula for the midpoint. The midpoint is given by x1 plus x2 divided by 2 for the x value of the midpoint, and y2 plus y1 divided by 2 for the y value of the midpoint. Okay, so let's go ahead and apply it. We'll have 8 plus 8 divided by 2 and negative 6 plus 4 divided by 2. So 8 plus 8 is 16, minus 6 plus 4 is a negative 2. 16 divided by 2 is 8, and negative 2 divided by 2 is a negative 1. So our midpoint between these 2 points is this point, 8, negative 1. Okay, so please, if you have any questions, you need me to slow down, go ahead and put it on the chat or raise your hand. Okay, so let's go to the next one. Write the standard form of the equation of the circle with the given characteristics. So the characteristics here that they're giving us is they're giving us the center of the circle, which is at negative 4, 2, and they're giving us the radius. The radius is 2. So let's recall the formula or the standard form of the equation of a circle, which is given by this. X minus h squared plus y minus k squared is equal to r squared. Again, where h and k refer to the center and r refers to our radius. So it's just a matter of plugging in to our formula given. So here our h is negative 4, so we have x minus a negative 4 squared plus y minus a positive 2 squared is equal to our radius, which is 2 squared. So let's go ahead and simplify. So we have a negative with a negative is a positive. This stays the same, y minus 2 squared, and the 2 squared is equal to 4. Okay, so we were able to give the equation in standard form given these characteristics. Okay, all right. How about this one? Find the center and radius of the circle given this information. So again, If we know the standard form of a circle, we know that these values refer to the h and k. So it's all about plugging them in to this formula to be able to determine the center and its radius. So let's do first our h and k, which is our center. And again, these circles indicate what values we're interested in. Okay. Now, keep in mind here, we have the formula requires for a negative. So in this case here, since it's already a negative, for us to have got a negative here, we know that the 1 had to be a positive, because a positive times a negative will give me a negative. And here, the formula requires a negative, and since this is a positive, the only way that I would have gotten a positive is with a negative with a negative. And on this one, to solve for the r, we see that we're going to have to take the square root property. Okay, so let's go ahead and do that. So here, again, is just what I described. We had a positive 1 with the negative 1, gave us the negative. To get the positive, we had to multiply by a negative, and the r squared is the 25, right? So we know that based on our formula, we can find our values, right? So our center here is going to be a positive 1 and a negative 2. What about our r squared? Again, we're going to apply our square root property. So to get the r by itself, we're going to take the square root of both sides. So that's going to give us r is equal to the square root of 25, and r is equal to 5. And again, we are only interested in the positive version of the distance, right? We don't measure negative distance, so we have a positive distance of 5. So our radius is 5. Okay. All right. Now, what if we needed to sketch the graph? Okay, so again, we want to start with our center points, and then we can apply our radius information to do a sketch of our graph. So here, our center is 1, negative 2. Our radius is 5. Okay. So if we were to plot, we would plot first our center. So our center is 1 unit to the right and 2 units down. That's our 1, negative 2. Okay. And we know that the radius is 5. So all directions from the center should be a distance of 5, right? So we can go ahead and do 1 to the right, 5 units to the right, 5 units up, 5 units to the left of our center, and 5 units down from our center. And again, we know that this is a circle, so we would try to draw, if we were sketching it by hand, we try to do a smooth round circle. Okay, but again, we're doing this on WebAssign, so WebAssign will create our perfect circle given the 2 points. Okay, all right, so let's go to the next set of problems. Says find any intercepts and test for symmetry with respect to both axis and the origin. So let's start with the intercept. So we know that we have here a linear equation, and if we want to find the x-intercept, we're going to set y equal to 0. And if we want to find the y-intercept, we'll set x equal to 0. And then we have some rules to find whether we have symmetry. Okay. So let's find the x-intercept first. And again, we're going to set y equals to 0 and solve for x to get our x-intercept. So this is our equation, y equals negative 4x plus 1. We set y equals to 0, and let's solve for x. We're going to subtract 1 on both sides. And then we're going to get negative 1 equals negative 4x. Then we're going to divide by a negative 4 on both sides. Okay, and when we do that, we have a negative 1 divided by negative 4 is going to be a positive 1/4. And again, a negative 4 divided by 4 is just 1, gives us the x. So our x-intercept as an ordered pair is given by the x value 1/4, and again, our y value is equal to 0. Let's go ahead and find our y-intercept. So to find our y-intercept, we set x equal to 0 and solve for y. So let's go ahead and do that. This is our equation. We set x equal to 0. So negative 4 times up 0 is going to be 0. This is just going to give us 0 plus 1, which we know is 1. So our y-intercept as an ordered pair is 0, 1. Now, let's test for symmetry, okay? So since this graph is a line. There is no symmetry in respect to our x or y axis or origin. Yes? All right. So let's find any intercepts and test for symmetry with respect to both axes and the origin. So again, the rules for the symmetry, again, if it's an x-axis symmetry, if we would change the negative for the y and it still gives us the same point, then it has the x-axis symmetry. So let's see some of the examples. Okay, so if we have here y is equal to negative 4x plus 1 and replace y with a negative 1 and solve for y, we should come up with the same equation. Okay, so here we do this. We have negative y is equal to negative 4x plus 1, and we're solve for y. In order for us to solve for y, we need to multiply by a negative 1 on both sides. And when we do that, or divide, whichever you like, when we do that, a negative with a negative is going to give us a positive, and a positive with a negative is going to give us a negative. So we see here that it's not the same equation that we start, right? We actually had to flip the signs. So therefore, it has no x-axis symmetry. So to test again the y-axis symmetry, we replace the x with a negative x, and again, solve to see if we get the exact same equation. So when I put in here a negative x, okay, I know that a negative times a negative is going to give me a positive, okay. So again, here again, we do not have the same equation, so this does not have y-axis symmetry. And the test for the origin is if we change both signs, we should get back the original equation. So let's go ahead and do that. Let's go ahead and replace both the x with a negative x and the y with a negative y. Let's simplify. So we have a negative y is equal to a positive 4x plus 1. And let's go ahead and multiply by a negative 1 or divide by a negative 1 on both sides. And when we do that, this gives us a negative 4x minus 1. And again, it's still not the original equation. So hence, this equation does not have any symmetry because it does not apply to any of our given tests. Yes? Okay. All right. So let's look at these 4 equations. Determine whether the equations represents y as a function of x. Okay. So let's start with the first one. We know that this is a line, right? This y is equal to x plus 4. We know that if we were to do our imaginary vertical line test, we would see that our imaginary vertical line only crosses the graph once. So hence, this is a function. Yes. Now, how about the second one? This a graph is a quadratic, and again, and if I apply my vertical line test to show if a graph is a function, I see that if I apply my vertical line, imaginary vertical line, my imaginary vertical line will only cross the graph only once. So this one also is a function. How about the square root of x minus 4? Okay, this is the graph of the square root of x minus 4. Again, I'm going to apply my vertical line test, and I can see that my vertical line only crosses my graph once. For every x value, I only have one y value. So hence, this equation is also a function. Okay. How about this last one? Oh, so we just saw this, right? This is I guess you can call it the general form of a circle, or this is when our center is at the origin at 0, 0. The h and k are 0. So if we see here that if we would apply our imaginary vertical line test, our line would cross our graph twice. So hence it fails that imaginary or that vertical line test. So hence this equation is not a function. Okay. All right. So let's look at these last two again, practicing or finding if a graph is a representation of a function. Again, and what we're doing with the vertical line test is showing that every x value has its own y value. So if I were to graph this one, x cubed minus 1, and again, thes's graphs are given to you on WebAssign. You just have to decide whether it's a function or not a function. Again, if I apply my imaginary vertical line, I see that this graph um, crosses my imaginary line only once. So it is a function. And then this last one, y squared is equal to x plus 4. Okay, we can simplify, right, to solve for y, and we take the square root of both sides, and we have these two equations, right? Y is equal to the square root of x plus 4, y is equal to the negative square root of x plus 4. So then if we see here that x, if it is equal to 0, we have two different answers, right? So without applying our vertical line test, we can see that we have, for one x value, we have two different y values. So this graph does not represent a function. Okay. And if we were looking at the graph, again, this is a sideways parabola. And again, you see that here our vertical line crosses it at 2 points. That for the x value 0, I have two different answers. I have a positive 2 and a negative 2. But this is not the only one. It crosses all these points. This graph always crosses it twice, right? So it fails our vertical line test. All right, so next one. Use the graph of f of x equals square root of x to write an equation for the function represented by each graph. Okay, so I see here, if I were to draw my parent function, the square root of x, I know that my parent function starts at the origin, and it's like this curve here. And if I see here, let's follow where this initial point was, right? So if we go here, thank you, Yvette. So they graphed my parent function, the square root of x. So let's see what happens to this graph. So I see that this graph, let's first look at what happened to our vertical shift. I see that from the origin, okay, if I were here at the origin, my graph went down 8 units, right? So I had a change in my vertical, so that was a change in my y, okay? And then if I do my horizontal, okay, I see that it was shifted to the left 2 units, right? So again, what this means is that this graph, okay, we did something to the y to move it down, and we did something to the x to move it to the left, okay? So here, we see that for us to move a graph to the left, we have to do the x plus 2. Now you're saying, but we moved it to the left. Wouldn't it be minus 2? Remember, you always want to think of solving for the x-intercept. If I had to solve for the x-intercept, for the x-intercept, I would set y equal to 0, right? So if I solve for x, I would have to take the square root of both sides and then subtract 2 on both sides. And you would see that x would be equal to the negative 2. Hence, that's why we have a plus 2. Even though you might think that we wanted to have a minus 2, because we have to move the 2 to the other side, it moved to the left, to the negative 2. Okay, so we have a shift to the left, 2 units to the left. And again, now outside the square root, we would be affecting our y value. And I had mentioned that we shifted our graph 8 units down. So in order to give the equation of this, okay, we would just subtract the minus 8. Now in this one, if it's a minus 8, it goes down. If it would have been the graph shifted up, it would have been a plus, because we don't have to move this number to the other side. We already have the y equals negative 8. Yes? Questions? All right, so let's look at this one. Use the graph of f of x equals square root of x to write an equation for the function represented by each graph. Okay, so this one's a little bit different, right? So again, this is the graph of my parent function. Okay, so its initial point is at the origin, and it has this curve. Okay, so the first thing I noticed, K2, okay, my curve is upside down, right? And in order for that to happen, that means we had a reflection on our x-axis. So I know that there's going to be a negative symbol in here somewhere. Okay. Also, I see that if I'm looking at my point shifted 2 units to the right. So we know how to handle that. So if we know that it got shifted 2 units to the right, we know that we're going to subtract 2 units to the x inside the radicand, right? And then the graph shifted down again, 1, 2, 3, 4, all the way up to negative 5. So let's see. So here, again, is our reflection that I was talking about, okay? So our graph had a negative outside the radical to reflective, but then you see it's also backwards. Not only did it get reflective, but it's also pointing the opposite direction. So in order for us to do that, we needed to also apply a negative to our x inside. Inside our x, we have a negative x, and that's going to flip our graph to the opposite direction, to the negative side. Yes? So again, now let's do the easy ones, the shifting. So I said we shifted it 2 units to the right. So we're going to subtract 2 to our square, to our x inside the radical. And we shifted it down 5 units. So outside the radical, we're going to have a minus 5. Yes? So the equation represented by this graph is negative square root of negative x minus 2, and then outside would be the negative 5. Be very careful on the computer. Make sure that you put a space after the 2, and you don't include the negative 5 inside the radicand, okay? Very, very, very easy to make this mistake, and you don't want to lose points on the test for something simple like that, okay? All right, let's move to the next set of equations. So it says here, write equations of the lines through the given point, parallel and perpendicular to the given line. So first of all, they give me this equation like in general form, where I have the 8x minus 2y equals to a constant. But in this format, I cannot tell what the slope is. And I need to know what the slope is. If I want to find out the equation of the line that's parallel to this line, I need to know the slope, because I know that parallel lines have the same slope. And if I wanted to find the perpendicular line to the given line, I still need to find the slope in order for me to get the opposite slope, right? Or to get the perpendicular slope. So let's do this. So in order for me to see what the slope is, what I'm going to do first is I'm going to convert this equation into the slope-intercept form. And by me doing that, it's going to tell me what the slope is. And then I'm going to use the point slope formula, because they want me to go through a given point. I'm going to use the point slope formula using this point to come up with my equation. Now I'm going to have to do a little extra work, because on WebAssign, they want us to give the answer in the slope-intercept format. Okay, so we'll have to do a little extra algebra. But first, let's get our slope. So first, to get our slope in slope-intercept form is solving for y. So I'm going to subtract an 8x on both sides. So this should be minus, let's see here, let's fix this. So this would have been minus 8x plus 3, and then I'm going to divide by a negative 2. So a negative 8 divided by a negative 2, this is a positive 4, okay? And then a positive 3 divided by a negative 2 is going to give me my negative 3/2. Now this point here, I am not interested in. All I'm interested in this point right here, because this is the m value. This is the value for slope. So my slope on the given equation is equals to 4. So if I want the parallel line that goes through this point, let's go ahead and use our point slope formula. Okay, so our point slope formula is given by this: y minus y1 is equal to m times x minus x1. I know my parallel slope, which has to be the same, which is 4, and I have my point. So let's go ahead and plug them in. So let's substitute. So we have y minus 1 is equal to 4 times x minus 8. So again, they want us to, for WebAssign, they don't want this answer. If they said just any equation, this would have been fine. But again, they want us to do a little bit of algebra. They want us to solve for y and want it in slope-intercept form. So let's go ahead and simplify and distribute first our 4. So 4 times x is going to give me the 4x. 4 times a minus 8 is going to give me a negative 32. Okay. Then the last thing I need to do is going to add 1 on both sides. And this is going to give me y is equal to 4x minus 31. So if you see here, this is a parallel to this given point because they have the same slope with different y-intercepts. The y-intercept on this one was a negative 3/2. The y-intercept on this one is a negative 31. But the important part was the slope. They have to have the same slope. All right, Let's go ahead and do our perpendicular. So we need the perpendicular slope. So I know to get the perpendicular slope, I always tell my students, I want the opposite of the slope. So first, the opposite of a positive would be a -4. And then the opposite of a fraction, right? This, if I consider this a fraction 4 over 1, I would take the reciprocal of this fraction, which would be 1 over 4. The numerator becomes the denominator becomes the numerator. So my perpendicular slope is -1/4. Again, I'm going to use the given 0.81, and I'm going to use the point slope formula once again to find that equation. So let's go ahead and substitute our values. Y minus 1 is equal to -1/4 x minus 8. Let's go ahead and distribute that -1/4. Okay, so we're going to get a -1/4 x times a -8 times a -1/4. Let's go ahead and simplify. Okay, so it's going to give us y minus 1 is equal to a -1/4 x plus 2, because the negative times the negative is a positive, and 8 divided by 4 is 2. So the last thing is add 1 on both sides, and we're going to get y is equal to -1/4 x plus 3. And this is my perpendicular equation to this given equation that goes through this point. Okay, so again, please stop me. I want to go through the whole review. I want to get as much as possible. But if you have any questions, please put them on the chat. Okay, so let's look at this one. Consider the following: f1 is equal to 7 and f0 is equal to 8. And they're asking me, write the linear function of f that has the given function values. So here it's telling me that when I plug in the value for x, which is 1, my output is 7. Let's look at this first one. Okay, so in order to find, we need at least one of the points, which we have, right? So here I have my input is 1 and my output is 7. So this one, my input is 0, my output is 8. So now that I have the 2 points, I can find my slope by applying the slope formula, so which is y2 minus y1 over x2 minus x1. And again, it doesn't matter which point you pick to be the first one, as long as you follow the formula. Okay, so again, I'm choosing 0.1 and 0.2 just the way they are. So when I do this, my slope is -1. So once I have my slope, I can pick one of these other points to find my y-intercept, right? So to find my y-intercept, okay, I'll just plug it in to the slope-intercept form. So I have a y value and I have an x value. Okay, I just need to find my b, right? Or you can use, or you can use the point slope formula, whichever you feel more comfortable with. Okay. So again, to do the first one, okay, let's substitute the values again. My f1 is equal to the x. So everywhere I see x, I'm going to plug in 1. So when I simplify, okay, I get that f1 is equal to a -5. Okay, so here I can plug it in, right? So to do x plus 4 for this function, I do the same thing. Everywhere I see x, I'm going to plug in this x plus 4. Okay, all right, so here I have the function 3x minus 8. Everywhere I see x plus 4, everywhere I see x, I'm going to plug in x plus 4. So we have 3 times x plus 4 minus 8. Let's simplify. So to simplify, I need to distribute. 3 times x is 3x. 3 times 4 is 12. We have the minus 8. We have two like terms. 12 minus 8 is going to give me a 4. So finding the function value when they're giving me the point, x plus 4, it gives me 3x plus 4. Okay. All right. Find the function value if possible. Okay. So here we have g of t is equal to 5t squared minus 6t. Okay. So what this means is, again, don't be scared. This is just the name, but everywhere I see t, I'm going to plug in 2. Okay. So let's go ahead and do that. So I have 5, 2 squared. Again, let's make sure that we put parentheses because we have a square, minus 6 times 2 plus 4. Okay. So let's go ahead and simplify. So 2 squared is 4. A -6 with a +2 is a -12 plus 4. So 5 times 4 is 20, minus 12 plus 4. So let's simplify. 20 minus 12 is a positive 8 plus 4, and 8 plus 4 is 12. So when my input value was 2, my output value, or y value, is 12. Okay. Yvette, would you like to do this one? Oh,
Sure.
I can continue.
Yes, I can continue.
Thank you.
All right. So for this one, if we want to figure out what g of t minus 2 is, then what we're going to do is plug in a t minus 2. And you want to take the entire thing that's in the parentheses and replace each of the t's. So here we get 5 times t minus 2 squared minus 6 times t minus 2 plus 4. Then we're going to simplify. So in my math lab, sometimes they let you put the answer like this, but on WebAssign, they do want you to simplify further. And so t minus 2 squared is just t minus 2 times t minus 2. And so we're going to multiply that out. So we get t times t is t squared. T times negative 2 is negative 2t. Negative 2 times t is negative 2t. And negative 2 times negative 2 is positive 4. And then we can combine like terms in the parentheses. So we have a negative 2 plus a negative 2 gives me a negative 4t. And then we're going to distribute the 5 into the parentheses. And we get 5 times t squared is 5t squared. 5 times negative 4t is negative 20t. And 5 times 4 is 20. And then we have the rest of the terms here, minus 6t, plus 12, and plus 4. So our last step is to combine all the like terms. So we get 5t squared. Then we have a 20t, a negative 20t plus a negative 6t will give me a negative 26t. And then 20 plus 12 plus 4 will give me a positive 36. Okay, so the idea here is no matter what you have in the parentheses here, you take everything there and substitute it in for the variables. Okay, so here we have it a little bit different. It almost looks like what we have here, t minus 2, but it does work a little bit different. So first we're going to do g of t, and then we'll apply g of 2. So for g of t, anywhere we see a t, we're going to replace it with itself, a t. So we're going to have 5t squared minus 6t plus 4. And if we simplify, then we end up with 5t squared minus 6t plus 4. In other words, this g of t is always going to be itself. Now for the g of 2, and I like to do them separate first so that we can see what each value is. G of 2, we're going to replace all the t's with the 2 and simplify. So 2 squared is 4. Negative 6 times 2 is negative 12. And then we have our plus 4. 5 times 4 is 20. Minus 12 plus 4 is equal to 12. Okay. So now that you have your two pieces, then we can actually answer the question, which was g of t minus g of t, g of 2. So g of t was 5t squared minus 6t plus 4, and g of 2 is our 12. So if we combine our like terms, then we get 5t squared minus 6t plus 4 minus 12 is negative 8. Okay, any questions on that? Okay, so for these functions, we also did operations on them. And so the first one here, we want to add function f with function g. And so one of the first things that I encourage people to do is to rewrite this the way it's defined. So f plus g of x is just equal to f of x plus g of x. And so wherever I have f of x here, I'm going to replace that with the given function. So in this case, x plus 2. And then for g of x, they tell me is x minus 2. And then we can gather our like terms. So x plus x is a 2x, and 2 minus 2 is 0. So our f plus g of x is equal to 2x. For subtraction, same idea, f minus g of x, I can rewrite it as f of x minus g of x. And then we have our function f, which is x plus 2, minus, and then here I always encourage the parentheses because this minus sign is going to be for everything in the parentheses here. So if you leave it out, then you're going to run into a problem where you don't apply it to the entire equation. And so once we have it written out this way, we can distribute this negative. So we get negative times x is negative x. Negative times a negative 2 is a positive 2. Gather our like terms. So we have x minus x is 0, and 2 plus 2 is equal to 4. For multiplication, same thing. We can rewrite it as f of x times g of x. So here we have x plus 2 times x minus 2. We're going to distribute or multiply this out. Some of you are familiar with FOIL. So here we go, x times x is x squared. X times negative 2 is negative 2x. 2 times x is a 2x, and 2 times negative 2 is going to be a negative 4. Gather your like terms. So we get x squared minus 2x plus 2x minus 4. And you can notice there that your negative 2x and your positive 2x are going to become 0. I'm sorry here. So let me make sure we did this one right. Yes, so this should be x squared minus a 4. Okay, so let me just rewrite it. Give me a second. Here. Okay, so we have, this term should not be here, so we should have x squared minus 4 would be our answer. Okay, so let's go to f divided by g of x. So here we're going to divide f of x divided by g of x. And so we end up with x plus 2 divided by x minus 2. We cannot simplify this further. So this is going to be our answer. Okay, and then the last part of the question is going to ask for the domain. And so remember that your domain is all the values that we can use for x. And so what I like to ask students here is there a fraction? If you have a fraction, that means that you're going to have a restriction. You're going to have some values of x that cannot be used. And those values are the ones that cause your denominator to be a 0. Okay, and so the way we figure out what those values are is we can take our denominator and set it equal to 0. And so we end up with x is equal to 2. So all of our values here, we can use everything except for negative 2. So in interval notation, we're going to write it as negative infinity to positive 2. Union, this is a symbol for and, which we call it a union, 2 to infinity. And notice that I use parentheses around the 2 because I do not want to include the value for 2. Okay, so that is how we would find the domain. So if you have fractions, you're going to have restrictions. If you have a square root, you're going to have restrictions. And in chapter 3 for 1314, and when you get to the exponential section in 1324, if you have a logarithmic function, then you'll also have some restrictions. Okay, so let's look at multiplying these two functions together. So here we have f of x times g of x. And so we're going to end up with x plus 3 times x squared minus 2. So we're going to multiply x times x squared, and then x times negative 2, and 3 times x squared, and 3 times negative 2. And so when we do that, we end up with x cubed minus 2x plus 3x squared minus 6. We'll combine our like terms, so we get x cubed plus 3x squared minus 2x minus 6. There's really nothing else that I can do to simplify, and so that was going to be my answer here. Okay, the other concept that is covered is this symbol here that kind of looks like multiplication, but notice that it's not filled in. So this is your composition. And so if you're given two functions, we would do the first thing is to rewrite f composed of g as f of g of x. The function that goes inside is going to be your second function listed here. Okay, so then we can substitute. We're going to evaluate g of x. So if we look at g of x is x minus 9. So I'm going to take this information and replace my g of x with x minus 9. Then I can evaluate my f of x, meaning that I'm going to take everything in the parentheses, which is x minus 9, and I'm going to substitute it in for my x in my function f. Okay, so that's going to look like x minus 9 for this x minus 9, plus 4. And then we can combine like terms. So we end up with x minus 5. Then for g composed of f, again, we rewrite it. Notice that my function f is inside, and that's because it's the second function listed here. And so f of x is x plus 4. So I'm going to take everything here and plug it in for my g of x. So I end up with x plus 4 minus 9, which gives me x minus 5. Now, if you notice for a and b, we got the same answer, but that is just a coincidence. That does not happen all the time. So let's look at g composed of g. So here we have g composed of g of x. G of x is x minus 9. So I'm going to take all of this x minus 9 and plug it in for my x here. So when I do that, I get x minus 9 minus 9, which gives me x minus 18. Any questions on the composition? Okay, there's a couple of more here. So for the first one here, we again rewrite it, f of g of x. G of x is x minus 1. And so now I'm going to take this whole x minus 1 and plug it in for my function f. So I'm going to have x minus 1 squared. If we simplify, we get x minus 1 times x minus 1. So we're going to end up with x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is a positive 1. So we end up with x squared minus 2x plus 1. For letter B, this time f of x is inside, which is x squared. So we're going to take our x squared and plug it in for my x here. So we end up with x squared minus 1. And so the composition of g of f of x is x squared minus 1. For g composed with g, we're going to have, so this should be a g here. So we're going to have g composed of g of x. And so we're going to plug in x minus 1 in for g, which is x minus 1 minus 1. So we end up with x minus 2. Okay, another concept that you'll be that we covered in chapter 1 is whether a function has an inverse. And so one of the things you want to check first is if the graph is actually a function. In this case, they tell you it's a function. But in order to figure out if it's going to have an inverse, we use a different test. Can anybody tell me what the name of that test is? You can throw it in the chat if you remember. And so that test is going to tell us whether it has an inverse. And so yes, that's correct, Ms. Nieves. So the horizontal line test will tell us if a function has an inverse. So basically, if you draw a horizontal line and it touches your graph in only one location, like it does here, then that means that it has an inverse. Okay. So our next question here is determine whether the function has an inverse. Well, this graph here, is this a circle, a parabola, a square root, a line, absolute value? What type of function is this if I was to graph it? A line. So if you draw a horizontal test on the line, then you know it's going to have an inverse. So to find it, to find it, the first step is replace your f of x with the y. So that's always your first step. So I end up with y equals 5x plus 4. Your second step is to switch your x with your y. And so here we're going to have x equals 5y plus 4. And then we're going to solve for y. So I'm going to subtract 4 on both sides. And if I subtract 4 on both sides, I get x minus 4 equals 5y. And then I'm going to divide by 5. So here I get x divided by 5. And negative 4 divided by 5. And so my inverse, I'm going to change my y into the symbol for inverse, which is f to the power of negative 1, and then your x of 1/5 x minus 4/5. So this is going to be your inverse. And so we do have about, how many minutes? 14 or something like that. So if you have questions, we can answer those for you since we have 14 minutes left. But we wanted to just let you all know that we wanted to do a quick little review because I know most of the 1314, 1324 instructors are testing this week. And so for some of you, your test might be due on Sunday, it might be due on Monday. And so just make sure that you check your computers, especially if you need to download a lockdown browser or something. Make sure you try it with time. And also, we just want to wish you well on your tests. We know that you got this, and so our tutors are here to help as well. And we're going to stay here for a few more minutes. So if you have any questions, feel free to put them in the chat or open your mics. And then I'll pass it on to Ms. Patricia or to one of the staff and see if they want to stop the recording, and then we can just answer questions as we go.
Thank you, Ms. Chuka, and thank you, Mr. Carizales, for the presentation. Also, thank you to Mr. Albert Isasi. Thank you, everyone, for coming. I'll be stopping the recording now, but feel free to ask questions. Either type it in chat, and don't forget to sign in